Well, good evening, Front Range front end friends. I'm James Steinbach. For those of you who've been around for a while, I'm one of our organizers together with Jason Spiller. I'm also giving tonight's talk. We're going to be working on responsive components, present and future. And tonight's talk is going to carry some information over from a few months ago. We had an awesome Q&A about the future of CSS with Miriam Suzanne earlier this year. And I caught the bug for container queries from Miriam's talk, and also it was the first time I think I've heard as much fleshed out as the information she provided on how to do it and how to actually work with the new syntax. And that kind of stuck in my head, and this talk grew out of Miriam's work. So I want to start off tonight with huge thank you to her. And making sure we give her plenty of credit that she is due for a lot of the information behind the second half of tonight's talk. So without further ado, responsive components, present and future. And as you might guess, before we get to present and future, we have to deal with the past. And this talk starts all the way back in 2010, good 11 years ago, with media queries. And media queries are one of the big three pillars of Ethan Marcotte's writing on responsive web design and development. And those three things are flexible grids, fluid image sizes, and media queries. Media queries are awesome, but they immediately left us thinking, hey, we need something more. We also need a way to style components based on their own properties, their own size. You see, media queries can change CSS for a given selector based on something that's true about the browser. This could be screen dimensions, how wide or how tall the browser is, screen resolution or pixel density. Is this an old CRT monitor with 1x density, or is this a newer, shinier, fancier 2x or 3x, 4x pixel density? We can measure those things and target them with media queries. Even device orientation. You can write media queries that tell if a user is holding their iPad in landscape or portrait mode. Pretty powerful. Even user preferences make it up to the media query level. We've got media queries that apply to a user's wish for increased contrast or reduced motion. And we can honor all of those and tailor our CSS to match by using media queries. But sometimes the things that are true about the state of the browser itself are not what we want for styling a given component. What we really want is components that we can style differently based on their own height, width, or similar attributes. What about the size of the element itself was the big question we came up with. Almost as soon as we had media queries, we wanted more. And for a long time, here was how we figured this out. And this is not a fun slide. This is a how it used to be slide. We had to figure out what size an element would be in a given responsive layout per like the global layout breakpoints. Then we would use multiple media queries, multiple breakpoints to toggle CSS narrow and wide versions off and on. And this was not fun. I remember writing the CSS. It was a much longer version, but essentially the pattern you're about to see here on the screen, which is not the good way. This is the pattern. So we'd start off with a narrow version of the CSS for our widget because we're going to start off thinking about a narrow mobile device. One column layout, and it's a narrow column. Eventually that becomes wider, smaller tablets, phone and landscape mode. And now we have a wide one column layout, so we want the wide version of this particular widget's styles to apply. And then we get to a two column layout, but now the columns are small again, so the widget's going to be narrow. So we have to go back to the narrow version, and we're going to repeat all that. And then we get to a wider two column layout, and now the widget gets to be wide again. Hooray! And so now we have to fix it again and go back to the wide version. And we've got a pair of CSS groups that we're just repeating. And that was just a terrible way to go. This is not how we want to do component styling. Yeah, I remember pages worth of this, hundreds of lines of CSS in a project I did thinking way back a decade or so ago. It was not fun. And that whole last slide we looked at doesn't even account for this scenario, which is, what do we do when we put the widget in a different place on the page? What if it's in the sidebar instead of the main content? The sidebar is always a narrow column, perhaps. And now we never want to toggle the wide styles on and off, and all our media queries now get that much more complicated because we have to account for a parent class in all the media queries. And it's just no. Yeah, this has been what we've had to deal with for a long time. But today, I want to talk about better ways to do this. So first off, let's look at some current techniques we have available to us for styling a component in a way that its layout responds to its own size. And we're going to start with some CSS methods, 3 of them in fact, and these are based on Flexbox and Grid. First, we can use Flexbox wrapping. If we set a component to be flex wrap and then give layout containers inside of it a flex basis value based on their ideal or minimum width, then that component will go from vertical stack to horizontal split when the component itself is wide enough to accommodate both flex basis values side by side. This source goes back to Jeffrey Croft, one of the earliest developers that I could find using this technique. And in real life, it looks like this. Sorry, the pens take a moment to load. There we go. The markup in these 3 versions of the component is identical. Nothing changes between the real skinny version, the medium width version, and the real wide version. The HTML is identical, and there are no CSS changes. It's just Flexbox saying, hey, when there's room based on the flex basis value of the content area and the photo or the image, when there's room for them both to stack or to move side by side horizontally, we're going to do that. And Flexbox is really handy like that. That's one way we can write components that respond to their own size. Let's take another use case, which is we have a component that's either going to be a vertical stack or a horizontal stack, and the change is a specific number, a width of the parent. So not flex basis on the children. This is going to be a technique that takes into account the parent component width, where we want this kind of breakpoint, if I can air quote that, to happen. And we're using flex basis and a calc function to toggle between row and or column and row at the right width of the parent. This source goes to Hayden. He wrote a couple articles about it early on. I don't know exactly why he called it the Holy Albatross, but that's fun. And it looks like this in CSS. The container width I've put into a custom property just so it'd be reusable. If you're going to put this pattern into a site, you could change the container width on any other instance of it and get a new version. So the parent has to be flex with a wrap enabled, and then the child will be allowed to grow, but then the flex basis is where the magic happens, and it's a calc function that multiplies the ideal container, or takes the ideal container width, then subtracts 100%, then multiplies it by just some obscenely large number. 999 isn't a special number, it's just big enough that it's always going to exceed the width of the parent. It's just that number there to blow things up. And what that does is it makes the layout of this component snap from stack to row at 720 pixels wide on the parent. And to see that in action, we're going to animation that changes the width of the parent container. And as soon as we cross that benchmark, the 2 narrower versions of that, we're in a vertical stack. And as soon as it's wide enough, we cross that 720 pixel marker, then we go to a horizontal row. Just Flexbox. We don't need any kind of fancy new syntax for that, just a weirdly complicated calc function. And Hayden's articles, I'm not going to get into the whole algorithmic math explanation for why that behaves, but Hayden has written about that. And the third solution we've got for layouts that respond to their own size, not to the browser size, is a CSS Grid technique. And this is great for gallery views. You've got maybe an unknown number of images or items or boxes in a grid pattern, columns and rows, and you just want there to be, based on an ideal width of 200 pixels per item, you just want there to be as many columns as you can fit in at a time. And Grid will let us do that with just a repeat function. And this repeat function takes the count value of autofit, fit as many columns in as you can. And then the ideal width for a column is a min-max function where it's going to be at least 200, but no more than 1 fraction. And the 1 fraction allows the grid to spread any remaining space out between all the columns until the point where there's room to stick an extra 200 pixel column in there, and then it will do that. But as long as there's extra space not being taken up by 200 pixel columns, all the columns that exist will be spread out proportionally with the space evenly divided. And we're going to see that in a code pen here again, animation changing the width of the grid itself. And every time we change the grid width and we have room for another column, we get it. But the grids are always evenly spaced, and the grid gap controls the spacing, and it's beautiful. And it is the awesomeness that CSS Grid has always promised to be. So there we have a grid whose inner layout responds to its own width. And there we have it. This is a feature I wanted to mention. It's not strictly speaking a component responding to its own size function, but if you do a lot of research and look up the relevant Smashing Magazine and CSS Tricks articles about topics like this, you'll find a lot of them discussing media query-less responsive components or layouts. And this is a way to scale a value without using media queries. But it's technically speaking, since it's almost always got a viewport with unit in it inside of the clamp function, it's technically still a viewport-based technique, although it doesn't actually use the media query syntax. So I'm not going to dive into it deeply tonight. Just wanted to mention it, though, so that you would have the ability to do some more research and dig into that one a little more. I'm going to pause for some questions. I see a couple coming in, because right now we're at the end of the CSS section of current techniques. And before we get into JS, Jack, yes. And you don't have to be nervous about the hardware looking like the way you're currently working. It's not like a great dev ergonomics kind of situation, but it gets the job done. And at the end of the day, if we're deploying working code that isn't breaking on users' devices or overloading them in terms of download or bandwidth usage, we don't have to be ashamed of our code. We can be proud of that. Why doesn't subtracting? See, it does. And that's part of the magic. Subtracting 100% from the target value means you get to a point where you're multiplying the 999 by 0 or by something positive. And when you multiply something positive, you get a really obscenely large number, and everything snaps to 100% because it can't be wider than its parent. But the flex basis is so wide that you can't ever have two of them side by side. But when subtracting 100% gets you a essentially negative value, multiplying that by 999 doesn't do anything, so you end up with a really tiny flex basis. And that allows Flexbox to put all of the elements in a horizontal row. I don't think that was the best explanation, which is why I would refer you back to Hayden's articles. And these slides are live HTML. There's a link at the bottom of the page, jds.li/resp-comps. That will take you to a different themed version of the slide deck from another conference I was at a month ago, but it's essentially the same content with a couple of update exceptions we'll get into in about 10-15 minutes. So you can find the links to Hayden's content right there in the live slide deck. So now there's a JavaScript technique that we should work on too, which is a really fantastic way to handle responsive components, because everything we've looked at so far has been layout changes. It's all been Flexbox and Grid. None of it has been changing colors or font sizes or padding or border radius or any of the other things we might want to change. But we could change all those things if we could just toggle a class on and off when an element reached a certain size, an element breakpoint. Enter ResizeObserver. This is a JavaScript API that's in all major browsers, really well supported. It'll let you watch an element's size, and then you can add, remove classes, or make any other DOM manipulations that you want to when the size crosses a certain threshold. There's a link here to Mozilla Developer Network with some examples and how the syntax works. I'm going to briefly cover it for you here. If you were going to use this in real life, we would instantiate a new ResizeObserver. I'm going to save it as RO for now. Its callback function gets an array of entries, and then we loop through those. The third through fifth lines here are just a normalizing thing, because unfortunately Firefox returns an array of border box size objects, with the active one being the first object in the array. And other browsers do a much simpler thing and just return the border box size object, because at this point we're talking about a single node. So yeah, I'm not sure why Firefox gives us an array and if or when they're going to fix that. But for now, we have that. So ignore that part too much. And now we're going to change the action. If the size is greater than or equal to 480 pixels, we're going to add a class. And if it's not, then we're going to remove the class, and the class is simply wide. Once we've got that all set up, we're going to tell our ResizeObserver to observe a DOM node. In this case, we're going to get an element by ID and observe it. And this is much better in terms of browser performance than setting a ResizeObserver on, say, the window, which has been, like, for a long time, the only place we could really watch for resize events, right? The window itself. We don't have to do that. With ResizeObserver, we can watch individual elements. This is a very similar API to Intersection Observer. If you're used to that one, give that a try. Lets you tell whether elements are on the screen or not. And there's a mutation observer as well among the newer browser APIs, which is also a great way to watch for changes happening to a given DOM node. But this shows up in real life. As our card changes width, you'll see the class change. We drop the word wide when it's narrow. And then when it's wide, we add the class, and that class switches the background color and the text color. So here we can change any properties we want to with a really well-supported browser API. And you might be thinking, you said really well supported, but that's not 100%. How good is it? Well, globally speaking, it's good for 92.2% of like global traffic. If we change it to US traffic, I think it gets a little closer to 95 or so. It's an even higher number. If we're only measuring US traffic, your browser support needs, of course, depend on your traffic, not just global or US-based numbers. And you can see the only real holdouts here are Edge before it turned into Chrome and IE. Opera Mini and an Android browser are there. But let's talk about how we can support browsers that don't have ResizeObserver built in. The first and kind of low-hanging fruit solution is there's a polyfill. You pull that into your app if it's needed. Bundle it separately so you're not making the whole JS app larger, just for a few browsers that are kind of legacy. But you can bring in a ResizeObserver polyfill and use that. I've been on projects a couple years ago where this is how we solved it. But I would suggest a different solution that you should use whenever you can get away with that, and that is this. Use ResizeObserver as progressive enhancement. So start with maybe the narrow version of your CSS, the thing that's not going to break on a mobile device. Then browsers that understand ResizeObserver get the ability to toggle on and off the wide class or whatever name you choose. And browsers that don't simply keep showing the small CSS version of the widget, that set of styles, no matter how wide the component gets. And stretching a small thing till it's uncomfortably wide may not be the most attractive solution. It's not pixel parity. Edge 12 isn't going to look the same as Edge 90 something or whatever we're up to now, 70 something. I don't know. But it's going to be readable. It's going to be legible, usable, and hopefully as accessible as it would be otherwise. So you've got the ability to treat this as a progressive enhancement and to, I think, sell design and product stakeholders on that idea, rather than loading more JavaScript into the page to make some legacy, not modern, legacy browsers try to keep up. Of course, with any JavaScript observer we're doing, like add event listener, remove event listener, if you're going to be tearing things down and not leaving those markers, those observers running in the browser memory, you can unobserve as well. And with that, I'm going to pause for about 30 seconds and let the live stream viewers catch up. If you have questions, now's a great time to throw them into the chat. And as we move forward, we're going to look at what comes next. So we covered the past, didn't have a section of the slide deck really heavily targeting that, but media queries. We realized immediately we need more. We need to be able to do something that's going to respond to the size of a component itself. And given time, Flexbox and Grid answered that call in certain methods, certain techniques that relate to Flexbox and Grid with CSS. And then JavaScript gives us a ton of power with the ResizeObserver API. You'll be thinking, well, if ResizeObserver does everything it does, why would we want anything different? We just toggle classes and throw all our CSS behind a class like we've done for years. Seems reasonable, or if you're in a framework CSS and JavaScript kind of situation, throw all your changes behind a prop or a state value that you're pulling into your CSS functions. The future is container queries. And the reason why we would prefer that over the JavaScript solutions is ergonomically, it's a lot simpler for developers. Yeah, our CSS and JS libraries are going to have to make sure they update to cover the new syntax once it's live and hashed out by the specifications. That's fine. But not getting JavaScript involved in styling things is always, in my opinion, a good way to go, a good preference. And kind of relates to the idea of separation of concerns and using the tool with the least power to get the job done. If everything gets thrown into JavaScript and JavaScript is doing everything, then JavaScript is a single point of failure. One error that crops up in your bundle takes the whole thing down. And you might say, well, it doesn't matter if the whole thing goes down. It doesn't matter if you can see it with CSS or not. And that's a fair concern depending on your use case. But container queries will let us do all that and let the browser handle all the performance without us needing to add an extra 30 to however many lines of JavaScript. It'll just be there in our style sheet where all our styles live. Or again, like in a CSS JS context, it'll just be there in our CSS property object or template literal where all our other styles are. So container queries, and those of you who have been around for a while might say, hey, didn't these used to be called element queries? And you're absolutely right, they did. And before then, they were selector queries. All the way back in 2011, a developer named Andy Hume was working out a little JavaScript library that you could add to your site client side and then use a data attribute syntax that roughly approximated media query measurements, and then it would toggle classes on those elements and you could style them. And it wasn't super duper performant by today's standards, but it was 2011. And those of you who have been keeping track of the numbers and the dates in tonight's talk, yes, that's barely a year after media queries were like, one of the three pillars of responsive web design. Media queries had existed for a while before Ethan's work in 2010. But yeah, we're less than a year after RWD becomes a thing. And boom, we've already moved past media queries and somebody wants something better. The word selector got replaced over time by element queries a couple years later. Tyson's article, I think that's either on Smashing Magazine or CSS Tricks. I can't remember exactly. Smashing will be my bet. Came out and he's calling them element queries. And then less than 2 years later, we've got Philip Zastro speaking at CSS DevConf. And now he's bringing in the idea of container-based responsive web development with element queries, still using the word element, but getting the word container involved. So why the changes in terminology? And also, it's 10 years since 2011. Why are we still working this out? Why hasn't this been in browsers since like 2017 or something? I don't know. Loops are the problem. This is an imaginary syntax. Do not try :query. It does not work. It's nothing. But it was good enough for an example in this slide. Let's say you have an element. You make it 400 pixels wide. Then this browser goes to the next CSS declaration block and says, it's got to match a query. Is it more than 300 pixels wide? Yes, 400 is more than 300. So make it 200 pixels wide. And as soon as a browser does that, the query no longer applies. That selector doesn't match anymore. So now the element goes back to 400 pixels wide. And as soon as it does, the query matches and now goes to 200 pixels wide. And as soon as it's 200, the query no longer matches. So the element's back to 400 pixels wide. But as soon as it's 400 pixels wide again, the query matches. And now we're down to 200. And we've written an endless loop. We've written a block of styles, if this were a real syntax and were doable, that would send browsers, layout engines into infinite loops. And you just can't have that. Like that's been a core part of like CSS philosophy is like stuff might look wonky, but like you can't break the page. CSS shouldn't cause an endless loop. That's a little much. So we don't want that to happen. And browser vendors didn't want that to happen. And specification authors didn't want that to happen. Nobody wanted this to happen. So we didn't get this. The way that the specification authors, the CSS working group, and browser vendors have approached a solution is to separate the idea of a container from an element itself. So the solution we have now is an element can be styled based on the size of its container, an element that contains it. So solution here, container queries is what we have now. And again, I want to give a huge shout out to Miriam Suzanne. If you're on our YouTube page, you can look back maybe 3 talks or so ago, and we've got a Q&A with Miriam, and it is fantastic and amazingly informative and awesome. And I wanted to make sure I was extra clear about who to give credit to in this slide. If you've been around tech for a while, you may have observed a problem, which is sometimes somebody really clever and creative and intelligent comes up with something awesome. And they deserve a lot of credit for it. But what happens is somebody else, not pointing fingers specifically, but statistically more often than not, a white guy, will repeat that louder in his own way in front of his Twitter audience, and everybody goes, ooh, and suddenly that person, that repeater, has all the credit and all the attention. And I don't want that to happen tonight. I'm not getting any credit for what's happening here. Whatever happens after this point is awesome, cool things I've learned from Miriam, and I want to make sure, absolutely sure, that there's no confusion about that and that I'm not accidentally getting credit for it. So if you're online and you feel like clapping in the quiet of your own home or wherever you're watching from, yeah, we can give Miriam a quick round of applause. She absolutely deserves it. And if you want to follow her on Twitter, there's a lot of cool fun there too. And also great person to follow for updates on the specification because she is the author. So yeah, props to Miriam. Let's dig in. I gave a version of this talk in early November that was pre-recorded. So really I gave it in like mid-October. And the specification has shifted a little bit. Actually, this afternoon I spent a while rewriting my slide deck in this section because I pulled up supporting browser for container queries and nothing worked. And so Miriam was awesome. I messaged her on Twitter and got a reply, and she was great, explained what exactly had changed and why. But the first thing we have to do is create a container. This is not the element you want to style. This is the element that holds it, like a parent element, a container. And to do that, we assign it a container type. There are 3 values here as the specification currently stands. They are size, which is height and width, or inline size, which is from the beginning of or to the end of a line of text, which for those of us who use left to right or right to left writing modes or languages, that would be width. Those are left to right languages: English, French, Spanish, Greek, Russian, a whole host of other languages. And right to left, Hebrew and Arabic being the main languages in that group. Those are still both horizontal. Even though one goes from left to right and the other from right to left, they're still horizontal. So an inline measurement, the start to the end of a line of text, is width. Fun fact, CSS is shifting in a way to give us more power than just having height and width or left, right, top, bottom at our disposal. And they're giving us new ways to locate our dimensions or our measurements, which are called logical properties. The old ways, top, right, bottom, left, height, width, were called physical properties. But we can define things with logical properties, which take writing mode into account. So you've got keywords like start and end in flexbox and grid values. Those respond to writing mode. If you switch that site, translate it as in Hebrew or Arabic, and properly mark its language in your markup, the site will automatically flip the layout on a flexbox container or a grid container. It's the awesomest thing. I love it. But you may have heard of the CJK language group. That includes Chinese, Japanese, and Korean, a number of languages whose scripts are written in columns. A line of text is a column, not a row. And in that case, the inline measurement will actually go from top to bottom, from the beginning to the end of a line of text. It just happens to be a column now and not a row. And block size is the counterpoint. Block size is the start to the end of a block of text. So in horizontal, left to right, and right to left, it's the height. And in vertical writing mode, like with Chinese, Japanese, and Korean scripts, it's actually going to be the width because it's a start to the end of a block of text. Several columns make a paragraph or a block. So that's why we've got inline size here, and not just the word width, which might have felt like a more natural solution. This is new specifications being written to take advantage of the new positioning properties we have, logical properties, not physical. This spec is still a work in progress. Things are being changed about it on a semi-regular basis. So this slide is probably the quickest slide to go out of style in this talk. But here's the result. When you tell an element to be a container, it disables content-based sizing. So in this case, we're setting inline size as a container type. So the elements inside of this page content element will not give it any width. Its width will in no way be dependent on the elements inside of it. And that's how browsers are breaking the loop. Because the children can't change a parent's size, then resizing or restyling children based on a parent width can't break the parent, and it can't cause an endless loop. So you have to make sure your container is sized correctly. A width, whether in percentage or something like that, or having it inside of a flex or grid layout that gives it width, stretches it from edge to edge. Make sure that you're giving the parent here, this container, a width, because its children will not. It will have no intrinsic width on behalf of its children. And this is kind of analogous, I think, as an old school CSS person, to the way float-based layouts used to work. This one, when I first ran into it, I was like, what on earth? Why? We used to have to make columns by floating elements with like percentage-based widths and then letting them flow next to each other. It was not the best way to CSS things. And if you've been around doing CSS for a decade or more, you've been there, and yeah, we all remember that was like. But the fun thing was when you float all the elements, they don't give the parent any height. So your parent element you expect to be like this because it's full of floated columns, but it's not. The parent element is exactly this high, 0 pixels, because everything inside of it is floated. So now borders or background colors you put on the parent just wouldn't work. So we had to have clear fixes. And that was a horrible, hacky workaround. It got the job done. I shouldn't say horrible, but it was a kind of a clumsy, hacky workaround in some ways. And it fixed the layout, but this kind of does the same thing. Your parent container collapses on whatever axis you specify, inline or block, because its children can't give it any width or height. Step 2, style your children. We've got our widget again. We're going to start with its narrow CSS. Then, if that widget is in a container whose size is at least 480 pixels, boom, we give it wide CSS. And now all the widget cares about is the element that has been declared to be an inline container, and it's going to get the wide CSS appropriately. And each widget queries all its potential containers, which you might be thinking, what if they're nested? Yep, they could be. And that's totally fine. We're going to look at what to do if things are getting confused that way. Excuse me. But even if a container is nested in another container, the children will just query up the DOM. If there's a conflict, 2 different container queries causing 2 different values to the same property, then the closer container will have priority. It'll override the nearer ancestor, not the farther. But each widget will query all its potential containers and see what it needs to do to resolve. And step 3 should just be profit, but I did stick another one in there. If you need to name your containers, because this is kind of where you might jump logically after realizing, oh, we could have containers nested in containers, and one container might be a sidebar, and one container might be the main content, and one container might be the footer, and they're all different widths, each of those containers. So what do we do? You can give a container a name. Besides the container type, which we saw a few slides ago, you can also use a container name property to assign it an identifier. And this is essentially a lot like grid area. You can use whatever words you want to name a grid area. Here in this case, we're naming our first container main, and then the main contains a gallery, which we're going to name gallery. And so now our widget, let's say this is like a news site, and the widget is a featured image, a headline, a blurb, and some tags, and then the read more link. And we've got a few different layouts, but these article cards might be just in the main content area, full width, the most important headline of the page. Or they might be in a gallery that's 3 cards wide, still in the main content area, still in page content or container main. But in that case, they're much narrower. And if you needed to have nuances based on which container is the small size, then you can name your container queries. And you can see we've stuck the words main and gallery in after the @container syntax before the size function. Cool feature. This is actually, if you're looking at the other slide deck and following along, and if you're watching this, days or weeks later, years later on YouTube, cool, thanks. I'm so glad you're here. But by then I will have published and put a link in the comments to an updated version of the slide deck. The word size attached to that parentheses is a new feature. It wasn't there a couple months ago. I think September is when they hashed out that update. And this is super cool. I don't have a slide for this, but I'm stoked. Size is one function we can use to say what's being queried. But we could also say container main style, and then query a custom a property value pair from CSS, and put that inside. And that's going to be really wild because if I understand it correctly, we're going to have the ability to style elements based on CSS property value pairs that are true on a parent, which is going to be a blast, and I cannot wait for that. But yeah, here's what that looks like in real life. We have the same example as before, where I have 3 copies of the exact same markup. And in fact, I let Flexbox stick around and control the layout. So I'm not controlling my layout with a container query, but the container query is jumping in to set a whole bunch of custom properties on things related to background and text colors, rotation on the buttons, Even the filter color being used on an image overlay, border radiuses are, wildly different. And all these changes have happened because container queries. So this pen that you currently see here, and if you're following along with the live slide deck, it's a new link there from the one that was published, the green background deck. But yeah, this is awesome. And this works in everybody's favorite part of the talk. I know, everybody kind of holds their breath. Please say lots of things. Please say lots of things. And I would love to say lots of things, but I'm not going to lie to you. This works in Chrome Canary with a feature flag enabled. And this is the part where everybody just kind of goes like, oh no, why couldn't it be better? Why couldn't it be more? Why can't this work in all the browsers yet? And the answer is it's still a work in progress. This hasn't been hashed out well enough for the WebKit and Quantum, I believe is Firefox's engine, teams to have implemented yet. Chrome is pushing the limits and testing out different syntaxes. Again, in preparing for tonight's talk, I pulled up the old version in Chrome Canary, and it didn't work at all because they changed the syntax and I needed to add the word size to all those min-width parentheses. This is rapidly changing, and it's being tested live in a very safe context, Chrome Canary with a flag. So there's a Can I Use page that will tell you when other browsers are adding support, and that would be a great place to follow along if you want updates, or again, as I mentioned earlier, following Miriam Suzanne on Twitter would be another amazing place to follow along for updates. What if you really, really, really want to use it today, but your entire user base isn't using Chrome Canary with the feature flag enabled? Oh, and if you're curious about feature flags, you go to chrome://flags in your browser's URL bar, and that's where you can change it. It's got a search or a filter field that you can just type in container queries, and it'll autocomplete for you and let you adjust the flag. But if you need a polyfill, there's a dev named Jonathan Neal who's written CQFill. This is kind of a 1-2 punch to solve the problem. It's client-side JavaScript and it's a post CSS plugin, and the two of those work together to ensure that the stuff that goes to the browsers is all current, modern, standard CSS, but that behaves like it's actually got a real working container query. If you want more information, there's a ton to read here from the very first initial proposal from David Barron on container queries. Miriam has written so much. This explainer site, it's an awesome, awesome file. Right up at the current syntax, Mozilla Developer Networks page, even the CSS Working Group's current draft specification. All that's public, available to read if you want to dig into the nitty-gritty of it. And I want to close with a little call to action. What can we do? I mean, we can't make more browsers, just implement it. We can't write them strongly worded letters and force their hands here. I mean, you can try. I've never tried writing a letter to the Safari dev team, but who knows? Might go somewhere. But what can we do right now? Here's what I want to recommend. We can use a polyfill, and that's actually meaningful. And it's not just meaningful for us getting to play with new stuff ahead of time. Using the polyfill is publicly meaningful in that whether the polyfill is coming from a CDN, that was kind of more the polyfills of yesteryear. Nowadays, if everything's being bundled, we're pulling in a polyfill from NPM. CDN statistics and NPM download stats are public information. And those are available to the CSS Working Group and browser vendors, and they do pay attention to them. So if there are multiple polyfills competing to solve the same problem, then you are going to see browser vendors adding a little extra weight to the syntax behind the most popular polyfills, particularly if there's one that's far and away the favorite. So you can use a polyfill. That actually helps move the needle with browser vendors and the specification team. You can also follow the CSS Working Group spec and join their discussion. It's a really low barrier to entry. It lives all on GitHub. So if you're a developer and you have a GitHub account, you're ready to go. You can jump in, find use cases that are as yet undefined or unexpected behaviors in certain browsers, and you can bring those things up in GitHub with the commenting system that's right there as part of a repo or a issue tracker. And then as browsers update their own feature implementation, ticketing systems or trackers, and make those publicly available, you can vote for the features you want to see. And that is the clearest of all, probably, signal to the browser vendors that this is really important, using the bug voting systems that the different vendors, browser companies maintain. So in the meantime, that's what we have available to us while we wait for this to wrap up. Going to give you another minute while I wrap up my concluding comments, but if you've got more questions, you want to throw those into the chat, I will stick around to answer a few of those as we wrap up. Thanks, y'all. You've been a really great audience, I think. I don't know. I'm not in your house. I can't see you. So I'm just going to trust and compliment you for being a great audience. I really enjoy being here with Front Range Front End, and speaking here is really one of the highlights of my year when I get the opportunity to do it. So thank you so much for attending. It really means a lot to me that you spent your time tonight watching. If you want to follow up, have more conversations about this, even outside of YouTube, or you're coming to YouTube late and the live chat isn't running, or years down the road, whatever, you can get a hold of me at JD Steinbach. I'm the JD Steinbach on Twitter, GitHub.com for my blog. I'm currently senior engineer at Auth0, and we're hiring. So if you like to work with JavaScript and you want to make the world more secure by helping companies manage identities and logins in a safe and secure way that doesn't make developers reinvent the wheel, by all means, hit me up. In fact, my team, I think, has an opening coming up pretty soon. So if you know Node and React and you're comfortable with a little bit of server, a little bit of client side, that's the kind of hybrid we're looking for. So if that's you, slide into my DMs on Twitter, and I can make sure that we've had a good conversation. I've got the application link ready to go before it gets posted even. So yeah, I'm looking for great people to come work with me. So if that's something that interests you, let me know. And yeah, thank you so much for the comments. And I'm going to wrap things up. Again, this is Front Range Front End. When we meet in person, we meet in Denver. And looking forward to meeting again in person someday. I'm looking forward to whenever that's safe to do again. Till then, we've got YouTube, and we're happy to keep meeting with you, sharing content, and keeping this moving forward there. If you have a talk you'd like to give, frontrangefrontend.com is a place to go. We've got a button halfway down the page that takes you to a form where you can submit a talk you would like to give. And we are so thrilled when people who don't have a lot of speaking experience come up and they're like, hey, I would love to give a talk. Can I do it with you? And right now, while we're still remote, that means you don't have to be anywhere near Denver. If you're kind of wanting to break into or test the waters of public speaking, dev relations, that kind of a experience, by all means, hit us up. We're thrilled to have new applicants. And also, we've got a form there. If you just have a topic that you want to learn about and you would like our meetup group to come up with a speaker who's capable of giving a talk on that topic, same thing, frontrangefrontend.com. And that's a great place to request a topic that particularly interests you about front-end development. So all that to say, thanks so much for attending. Have a great night, and take care, everyone. Stay safe.